Hello guys, so in this video we will be solving invert a binary tree question. So this is a problem statement and this is what it looks like. So if this is a tree, we have to invert it, like every node's left element will be swapped with the right node. So if you see here, 4's left and right are swapped, 7's left and right are swapped, as well as the 2's left and right are swapped. So there are like couple of two ways how we can do this. If you noticed that this is kind of a pre-order traversal, like at every node we first visit the node, then we go to the children, right? In pre-order, that's how we can solve this question as well. Like when we visit the first node, we will swap its left and right nodes, then we will go move to its children. So let's get to work. First I will be solving this recursively, and then I will be doing it iteratively as well. So if not root, we will just return root. Since it is a pre-order traversal, now we know that we first visit the root, right? So we will perform the action right here. So root dot left comma root dot right equal to root dot right comma root dot left. So now the swapping has done. Now we will call the same function. So this is like pre-order, right? So we will be calling the same function like this with the left node. Even though it is swapped, we will be calling it with the left node. It wouldn't really matter, but let's stick to it. Root dot left and root dot right. Return root. Yep, that's about it. This is the recursive solution. If you see, it matches it, and if I submit it, it is accepted. So this is the recursive solution for inverting a binary tree. Now let's go ahead and code the iterative solution as well. So for iterative solution, what I will be doing, I'll be doing type of like level order traversal, we can say. So I'll first take the 4, and before adding those the children nodes, I'll be swapping them beforehand. Like I will swap 7 and 2, and then I'll add 7 as the left node and 2 as the right node, and keep doing that unless all the nodes are been traversed. So let's go with it. First of all, I'll import the DQ from collections, import DQ. Now I have imported DQ. Saying if not root, I'll just return the root. If it is null, we don't have to do anything. Now I will initialize the queue DQ with the root node, while queue number of nodes at this level would be length of queue, right? Now I know for I in range number of nodes, I will pop the node from the queue. I'll keep popping the nodes at that level from the queue. And remember, like it is possible to have a null node appended to the queue, because we still need that node to reverse it. Like every node we have, suppose there was this 3 was not there and it was null, we would still be appending it just in case. Suppose this one had a different node in here, we want all the nodes at this level to be traversed. So this is my idea. So what I will be doing is, I'll do something like this: node equal to q dot pop left Now, since the null node is also, I'm also appending the null node, we just keep in mind if node, that is, if the null node is popped, we don't have to do anything with it, we just disregard it. Now here I will be performing the swap. Node dot left comma node dot right equal to node dot right comma node dot left, and q dot append node dot left q dot append node dot right. Even if it is node dot, even if the left or right node is a null, we will still be appending it. Since we are taking this condition here, we won't run into any error. Now that we have done this, we know that we have inverted the tree. We will just return the root. It's showing the correct output, it's submitted, and it is accepted. Alright, this is the final code for iterative, and the recursive one is this one. Alright, thank you guys.